जाने क्यों रंगों. Hello everyone. Today we'll discuss about the Dijkstra's algorithm. So just give me a second here. So let's understand what is the approach. Then we will discuss the key points along with the implementation and this one, time complexity and the space complexity. So let's go with the this one approach first. So Dijkstra's algorithm, basically it is a greedy algorithm. So if you don't know greedy algorithm, I have already explained the greedy algorithm, how it works by taking the example and the problem. So you can just watch that one. So basically Dijkstra's algorithm is a greedy algorithm. So I'll just make it G here. It's a greedy algorithm. So basically it is used to find the shortest path from the source node to all other nodes, to find the shortest paths from source to all other nodes. Suppose I'll just consider in this way. So from the source to all other nodes, if you want to find the shortest path, we'll be making use of the Dijkstra's algorithm. So mainly in a weighted graph. So this is one thing. So it operates by maintaining a list of shortest distance to each node, and we will be iteratively selecting the unvisited node with the smallest known distance. So this is important. We will be this one iteratively. So I'll just write here. We will be iteratively selecting the unvisited node with the smallest known distance. So unvisited nodes here will be iteratively selecting the unvisited nodes with the smallest distance. So this is very important. So the next step is once a node is selected, then its neighbors are updated with potential shortest path distance. Once we select the node, once a node is selected here, what we will do, we will so its neighbors are updated with the potential shortest path distance. So its neighbors are updated with shortest path distance. So that's what we will be doing here. This is the third step. Finally, after this, the algorithm will repeat until all the nodes have been visited or no further improvements can be made. So we will be repeating here, right? So repeat algo. I can just write here. The algorithm will repeat itself until all the nodes have been visited or no further improvements can be made. So what are the key points to note here? We are maintaining first, let's try to write the code and understand instead of the explanation. Let's just try to write the code and understand. And also after that, let's consider the example, and finally we'll discuss about the time complexity as well as the space complexity. So initially, let me consider function Dijkstra of the parameters. I'll just consider graph and start node, nothing but start. So here n basically represents the number of nodes in the graph. I can just consider in this way. N is nothing but the number of nodes in the graph, right? Nothing but the length of the graph. So here next step is we will initialize the array distance to store the shortest known distance from the start node to every other node. Let's initialize. This is easy. I'll just give here distances, new array of n, and let's fill this one with infinity, right? I hope this is clear. Next, let's create one more array visited to track whether a node's shortest distance has been finalized or not. Initially, we will mark all the nodes as unvisited, right? So let's create the array visited here to track whether node's shortest path distance has been finalized or not. So I'll just give here new array of n, and let's fill this one with false. So I hope this is clear. So next, let's set the distance to the start itself, to the start node itself to 0. Because basically here the distance from the node to itself is always 0, as we had discussed, right? So the distance from node to itself will always be 0. Here I can consider here like this, distances of start. I can just initialize this one to 0. So here after the this one initialization, we have to go with the iteration, nothing but here the main loop runs n-1 times, where n is number of nodes, and this ensures we are processing each node only once. So initially I'll just consider here for let I equals 0, I less than n-1. Finally, let's increment the I. As I said, the main this is the main loop, and it will run n-1 times, where n is nothing but number of nodes, right? So next we will make use of the minimum distance variable, or min distance, and we will set this one to infinity. Why? Because this is just a variable to track the smallest distance that is found in the current iteration. So we need the shortest path, right? So I'll just give here min distance. This one, let me set this one to infinity. Finally, we will store the index of the node with the smallest distance. So I'll just give here that u equals -1. So here the loop next we are writing here we will be writing, because we have to find the node with the smallest distance among the unvisited nodes, right? So let me write in this way for let j equals 0, j less than n, and j plus plus. So finally, if not of visited of j or visited of j equals undefined, both works, and distances of j less than, it has to be lesser than the min distance. I have considered the variable min distance, right? Yeah, min distance. Finally, we have to update the smallest distance, and also we will set the u to the node with the smallest distance. So I can write in this way. This one will be min distance equals distances j. Finally, we'll set the u to j. Nothing but here we'll set u to the node with the smallest distance. I hope this is clear. Finally, if no node was found, that is, if all the remaining nodes are unreachable, then we will break out of the loop. So here it will be if u equals -1, then we will set this one to true. Nothing but here no node is found, node was found. Here nothing but if all the remaining nodes are unreachable, then we will we have to break out of that loop, right? So for that reason, so why have I written the true here? We have to break out of the loop. I'll just give here break. So finally, we will mark the node u as visited, because we are finalizing its shortest distance. This is simple. Visited of u, we will set this one to boolean value 2. This is I hope this is clear till here. Then we will come to the final step. Nothing but we have to iterate over. We are iterating over all the nodes to update the distance of the neighbors of the node u. So here this will be for let v equals 0, v less than n. So let me increment this one. Let's check if there is an edge from u to v. That is, graph of uv is not infinity, right? And v is not visited yet. So I can just write this one in this way. If graph of uv, if it is not equal to infinity and out of visited of v, so this one, then we can just calculate the potential new distance to the node v via node u. So I can just write in this way. I'll just consider the variable new distance. We have to calculate the new distance. I mean, new distance can be written in this way. Distances of u and plus graphs of u and v. I hope this is clear. So if the new distance is smaller, we have to update the distance for node V as well. So this is the final step. So here I'll just give here new distance. If it is lesser than the distances of V, we have to update the V as well, right? So distances V, we will set this one to new distance, nothing but we are updating, right? So I hope this is clear. Finally, what we will do, final step is we have to return the array. We have to return the array of shortest distances from the starting node to all other nodes. So basically we have the result in the distances, right? So just we need to return the distances here. So yeah, I hope this is clear. This is it for the code. Let's see, try to understand this one with the example. So I have considered the graph, this one. Basically the first line, this is nothing but the row 0, right? It will start from the, this is row 0 base. So row 0, nothing but distances from node 0 to others, 7 to node 1, 9 to node 2, etc. Here, this one, 7 to node 1, 9 to node 2, infinity, 14, etc. So yeah, same thing, row 1, row 2, row 3, row 4, row 5, until from row 0 to row 5 we have, right? So next step is we will start the node for Dijkstra's algorithm, that is initially a start node. We will give this one, initialize this one to 0. So I'll just give here start node. Let me initialize this one to 0. And let's calculate the shortest distance. Here, const distances equals, let me consider Dijkstra of graph and start node. So we are, after doing this, we have to print the result as well, right? So the result has to be 0, 7, 9, 20, 20 and 1. So let's see how can we print. I'll just make use of the console log of, let's see. Let me make use of the backticks here. Dijkstra's shortest distances I'll get. So I hope this one will be good. So here we have got the result in the distances, right? So let me mention distances here. Or I have considered, just give me a second here. Graph and start node I have considered here. This one has to be within the distances. I have not considered distances here. Sorry, this has to be small d. In small d, why this is not showing in the suggestion? Distances, Dijkstra of this one I have considered correct, right? So yeah, let's see. Let me run this one. So here, const visited, line number 5, not given equals. Okay, sorry. Here, let me give equals. So yeah, here we are getting the output Dijkstra's shortest distance 0, 7, 9, 20, 20 and 11. So this works absolutely correct. So the implementation works absolutely correct. So let's discuss the time complexity and the space complexity. So the time complexity would be big O of v to the power of 2 or big O of n to the power of 2 for adjacency matrix representation. So here, let me give here big O of vertices or nodes. So we can consider here, I'll just give big O of v to the power of 2, and the space complexity would be big O of v. Nothing but we are storing the distances and the visited nodes as well, right? So here the overall space complexity would be big O of v. So yeah. So this is it. I hope this is completely clear. So this is it. Thanks for watching, guys.